Okay, so I'm going to record this right now. So when the video is posted, you could come back and reference this. I'm going to make this nice and big. All right, so what's going to be on next week's quiz on Wednesday? By the way, we're meeting next week in person, Monday and Wednesday. So what's going to happen is the same format like we did before. When we meet in person, we'll do a review, but it's not going to be as extensive because you're going to have questions for me, or hopefully you will have questions for you. What do we need to concentrate on? We need to concentrate on Module 8. So let me get to Module 8. Module 8 basically goes over quadratics, how to find the vertex of a quadratic using the formula negative b over 2a. And we also did finding the value of a when we had the vertex form of the equation. And I want to bring this over here. Maybe I could put these side to side. And we can take a look. There you go. All right, so this is Module 8. Let's go back. Right here, Module 8. This is the video. So please look at this video here for Module 8, Functions of Multiplicity. Let's take a look at it now. I'm going to mute it.
Professor, I
Yes.
missed the docs, a quiz to review docs. I don't see a video.
I'm sorry?
I didn't see the video. I don't see your screen showing a quiz to review docs.
Oh, right now you don't see it? Can you see it now?
Yes.
Okay, great. Ooh, thank you. I really appreciate that. So on the right-hand side, you should see Module 8 and some notes that I took. And on the left-hand side, you should see a video. Yes?
Yes, thank you.
All right, awesome, awesome, awesome. Good, good, good. So if you look at this video, you're going to go over what we went over this video, which we did quadratics, how to find the vertex, meaning h and k, from a quadratic function. Everything is here. So I'm not going to like rewrite the book on this, but I want you to take a look at this video, and also finding the value of a from the vertex form of the equation. We also did increasing and decreasing functions, the difference between them, how to identify them. It should be towards right here, see? So decreasing, increasing, constant, decreasing. So these are some examples of, you can describe the behavior of the graph. Prior to that, we used trinomials and how to find the vertex form of the equation. We also had like a word problem, right? In this video, whereby you had 2 points. One was the y-intercept, and you had the vertex. I'm trying to see if it's oh, right here. This is it. Oh damn! I just passed it. I just passed. It was a word problem. This is more multiplicity towards the end. Right here. This is it. Determine the quadratic function whose graph is given, and here's the vertex, and here's the y-intercept. So this is a word problem, and then from this word problem, we were able to obtain the graph. So you need to practice this. Very important. And then from here, you could also find the value of a in the vertex form of the equation. I did all of this in this video. So you are responsible to do all of that. And then we jumped into multiplicity. And multiplicity, if it's odd, it crosses. If it's even, it touches. I went over that in this video as well. It's buffering now. I don't know why it's buffering so much. I guess everybody's going into the video. And we gave an example here, x plus 3, x minus 2, x minus 5. We said that the power here is 1, 1, 1, and then that means the equation is going to be x to the third. Based on that, you could determine turning points. So go over this video. All of that is there. And then at the end, we constructed the graph. And we laid out the x-intercepts, the y-intercept, and we graphed it. And we ended up with the end behavior here, x to the third, and we connected the dots. There it is. All right, so this finishes Module 8. This is the video on 1024, Module 8. Does everyone see that video? I hope you have access, because it works for me. I know it's there. Module 9. Module 9, exponential graphs and properties. So let's go into that. This was November 2nd. And these are all the videos that were done after the midterm. So here, we talked about what the difference between an increasing and a decreasing exponential, the properties of an exponential, that it starts at 0, 1, that the domain is going to be positive, negative, infinity, the range is 0 to positive infinity, and this is based on the horizontal asymptote. And we described that we had two graphs, one was increasing, the other one decreasing, and we gave their properties. So you need to go over this one more time, understand it. Then we went into transformations, and these transformations tell us that H controls left and right, while K controls up and down, as shown in this graph. And from this value here, we ended up with a -2 and a -3. So we go from 0, 1, we go where? We go to the left 2 units, and then we go down 3 units. We end up here. We draw our graph. It's going to look up. And there it is. There's our graph. So you need to go over these videos. I'm going to be asking, okay, so what's my horizontal asymptote? And you're going to be responsible to build it. Does it have to look perfect? No. But you do need to find this point. And this point is found from 0, 1 by moving 2 units to the left and going down 3 units. And then from there, based on the type of base that you have, it's going to be increasing. If you have a fraction, then it's going to be decreasing. And you got to label the horizontal asymptote. Of course, you're going to get partial credit. And you would be responsible for both increasing and decreasing graphs. All right. Let's continue. Transformations as well, as far as being reflected over the x-axis, and that occurs when we have the negative in front of our base. So whenever we have a negative in front of our base, it gets reflected over the x-axis. And it's all here. So you can't say, oh, you didn't go over that. You didn't teach us that. Yes, I did. It's all in the video. You could fast forward me, put me on 2x, 1x, 1.5x. Like your boyfriend, your husband, your girlfriend, your partner, they're going to become jealous of me seeing these videos all the time. And then from the exponentials, we moved on to the log world. And I explained what that meant. That means that we changed our x and our y's, and we introduced logs. And we said that logs, unlike exponentials, they start at 1, 0, because when you switch the 0 and the 1, you get 1, 0. And instead of having a horizontal asymptote, you're going to have a vertical asymptote. So everything changes. So now domain for a log will be restricted, but my range will be unlimited for both up and down. Unlike the exponential, that my domain is unlimited, but my range is restricted. And that's because of my horizontal asymptote for my exponential and for my vertical asymptote that would affect my domain. Now remember, logs, natural logs, and logs have vertical asymptotes. So this is a vertical line. So please keep that aware. And this is the video on November 2nd. And that's all we wrote. This is 1 hour and 20 minutes. So it's a pretty long video. Let's keep going. And the video prior to that was an hour and 26 minutes. So this is 1 hour, 26 minutes long. And then this video here, it's an hour and 16 minutes long. So you know there's plenty of material there. All right, so then our next video would be module 10. Yep. November, what is that? Module 10 right here. Boom. Open this up. Here's our video. And this is, I believe, the last time we met in class, right? No? Yep, because today's the 9th. And this video here was 42 minutes. It's 42 minutes. And what did we go over in our last video? In our last video, we continue with the logs, but here we explain the natural log. So here I'm going to move over to my iPad because I think it's going to look much better there. What was that? November? Was it November 2nd? Let's see what it is.
November 7th.
November 7th.
For the natural logs, it was November 7th.
November 7th. Oh, November 7th in the house. Did I actually write November 7th on the front? Let's see what it looks like. Come on, Mr. Restrepo, what did you do? Where did you start? Logs versus LN. Here it is. Perfect. Let me write this here. November 7th, 2022. All right, so I'm going to present my iPad. There you go, November 7th. So that's the video that we just did on Monday. All right, so what did we learn about natural logs? We learned that natural logs are ln, and they are derived from e to the x. That's the exponential equivalent. And what does e represent? It represents 2.718. And the way we write an exponential that has a base of e, we don't write it as log base e, we write it as ln x. And you're going to see that in the books. It's going to have the same characteristics of a base of 2x, 2 to the x. So it's going to look very similar to it. It's just going to pull a little towards the y-axis if it's an exponential, and it's also going to do the same thing if it's a log, and it's going to look increasing for the natural log because it is 2.718. However, if you're given a fraction like 1 over e, then that means it's 1 over 2.718, and that is a fraction, and then it's going to be a decreasing natural log. So if someone says their decreasing natural logs don't exist, that is incorrect because they do. Here's the graph, and you can prove otherwise. From there, and remember, these share the same characteristics of, excuse me, of regular logs. So everything regarding domain, everything regarding range, everything regarding the vertical asymptote, all of that is going to apply for the natural log as if it were a log. Then we went into properties for logs, and we mentioned product rule, quotient rule, and power rule. And I gave you the formulas, and then we applied them using some of the examples in the homework. Let me see if I did that in the video, so that way I don't have to go bonkers doing this all over again. And if you see my screen now, which I hope you do, it's going to be towards the end, right? Oh, look, I went over the homework on the video. That's pretty cool. And I said what to go over. Okay, that's not bad. All right. So we did a lot of stuff. Damn. All right, that's pretty good. And this is where we ended up. Let's see. Dun, 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 dun. All right, so here's the part of the homework that we explained. Okay, maybe it wasn't very well shown here. I could do it on the iPad. That's not a problem. So I'm gonna leave that running there, and I'm gonna go to my iPad now. There you go. Cool. All right, so in the example of the homework that I'm doing on the video, being that it wasn't very clear because I'm doing freehand, some of the examples from the homework was, I believe this is question 1, right? Question 1 stated, okay, so we have a log base 9, and we got 2x, and they're wanting to know which property you're going to use, and what does these two values tell us here? Which one of these are we going to use from the top?
The product rule.
Yep, we're going to use the product rule. So because we have something very similar to the product rule, we're going to then expand this, and we're going to say it's going to be log base 9 2 plus log base 9 x. And that's all we had to do. I mean, there was nothing else that because they weren't trying to like they didn't want us to resolve anything. In this type of situation, the only thing they wanted us is to expand it. So that was pretty fairly simple. That's not bad. Question number 2 had a different type of problem where we had, let's say, log base 9 over x. Was it a 9? Yeah, it was. And then which one are we going to use here? Are we going to use the product rule, quotient, or power rule? For log base 9 over x. Anybody?
Power.
We're going to use quotient. So here, this means log base 9, all right, minus log base 9 x. So now, can we do something here with this? This essentially is saying log base 9 is equal to y, right? So if we need to solve something like this, it would be 9 to the y is equal to 9. What value must y equal to in order to get 9? Because that's what we're doing here. 9 to the y, which is this. And this 9 here, which is x, right? This is our x value. This is our base. So the base to the y equals to 9. What does the value of y have to equal to make this true?
1.
1. That's it. So
Okay.
if we have log base 9 minus log base 9x, in reality, this is 1 minus log base 9x. Because this whole equation here is going to equal what? It's going to equal 1. All right. So I'm glad we're going over this. It's pretty good.
Professor, I have a question.
Who's that? Yeah, go ahead.
Me, Angelica. Okay, so either way, would it be correct or?
Yeah, either way is correct. But But if they
Listen,
ask
I
for
can't
full
take
sim,
it.
if they ask for full simplification,
Bill, I think.
Uh-huh.
Bill,
then
like,
they
no, you
want
have
to see a
come back.
1.
I'm like, sure about that? Let me check.
Okay,
Yeah, yeah,
got it.
yeah,
Thank
yeah,
you.
no problem. And then we had another example on the video. It was 2 log 2 plus 4 log x. So in this type of scenario, you guys are going to guide me. What do you guys think it's going to be?
Multiplication.
Yeah, correct. It's going to be multiplication. So now what happens there with the multiplication? What do I have to do there? What's my m? What's my n? We have to go back to this formula here. Log base b m plus log base b n. So what does that mean? Log base b m plus log base b n. All of this, right, is going to equal what? It's going to be log base b m times n. So knowing that that is the rule, what do I have to do here? Anybody? No?
Would it
Nobody?
be the 2 and the x? Or no?
Okay, so let's label this. This is my m, this is my n, right? And then this in green here can be expressed as what? We have a third rule up here, which is what? It's the power rule. The power rule says that if I have a number, let's say r, and it's log x, then I can move r here to the top, and vice versa. So this goes backwards and forwards, right? So this could be log x, and then this is r, right? That's what I did. So I could go either way. So what can I do with this 2? Can't I move it up here? What can I do with this 4? I can move it up there. So essentially, I could get what? I'm gonna get log 2, and I
Sure.
move that 2 value up there, and I have plus log x, and what am I moving up there? I'm gonna
4.
move that 4. So now I have this value here, right? So I can simplify that further by saying log base, not log base, nothing. I'm going to write log 4 plus log x to the 4th. And am I done? Am I done? No, I'm not done. Because what can I do with this? I can put this together. How can I put this together? I can put this using the product rule, which is log 4 times x to the 4th. And this is my final answer. So you have to understand the product rule, and you got to understand the power rule. We did quotient. Let's see. Let's see what else. What else can we do here? To see, these are some of the examples that need to get done. In the examples that I gave, has anybody done the homework for the properties of logs?
Yes.
No? Yeah. All right, Kyla, did you have any questions regarding it? I'm not going to give you the square root of anything. Was anything like catching your eye from the homework? Maybe? No?
Nothing I can think of, honestly. No. Thanks.
Okay, no problem. Cool. So having said that, I can't give anything more than what I gave on the homework, what I used on the examples, right? I'm gonna change my screen now to my desktop.
Oh, I'm sorry. Not doing good.
Oh, okay. So at minute 30 in this video from November 7th, this is where I started talking about properties of logs. Plus today's video is going to have the examples that I did today. Remember, I'm going to focus on those examples, and I hope you can see my screen now. Like for instance, number 1, number 2, questions like the one we just did, question number 5, right? You see the answers right there, log 4x to the 4th, and we worked this out. Work these problems out. And all of these videos are there to aid you, so that way we can meet in class in person on Monday, and if you have any further questions, then we'll work them out. I also wanted to bring to your attention, because I'm not going to teach you any new topics today. I mean, I think that's enough for the quiz on Wednesday. When is the final?
The 19th?
That is correct, ladies and gentlemen. What happens if you do not take the final?
Get a 0?
You get a 0 for the final, correct. There is no incomplete in the course. So if you were pulling a 66 prior to the final, and the final is worth 30 points, then what's going to be your grade?
66.
It's going to be a 66. It's going to be a D. There is no incomplete. So please make it your business to be there for the final. Math 104. Our room is going to be the same room, and this is going to be in person. And I wanted to record this, and I sent out an email because I don't want any smart guy or person or lady telling me, I didn't know. No one told me. I didn't get the email. I didn't see the video. Even on the site, I posted it today. So if you go on the site and you scroll, you can't tell me you didn't see this in red, hot red and yellow. So December 19th, mark your calendar. I understand some of you like to take cruises and trips and, you know, going to Mexico and Punta Cana and Dominican Republic or cruise. Well, guess what? The final's in person. You can't take it if you're on the cruise. So please have that in mind. Mark your calendar, plan accordingly. Usually when I was taking finals when I was a student, I did not tell my boss. I just called out sick. Because every time I told my boss that I was taking a final, oh my God, really? Oh, I can't afford to lose you today. A bunch of people called out sick and you're here. And you're like, but I told you I had to leave early. And I got tired of going through the same shenanigans. So the day of a final, whether it's my final or any final that I had to take, I was calling out sick. Oh, you're not feeling well. You can't make it. Nope, not feeling well. I'm sorry. Why? Because I didn't want to go through the drama. But that's me. That's me. Okay. You do what's best for you, but I'm just letting you know what worked for me.